All right, so guys, let's get started on the mechanics for this here problem. So I feel like Triphammer Road would probably be down in the south, so that's why I'm going to do kind of a southern accent on this part. All right, so here's the deal. For the mechanics, when you draw the picture, you're going to draw yourself a normal model, right? Why are we drawing a normal model though? Okay, well that was because here in the conditions we said that probably the sampling distribution would be nearly normal. Boom. That's what we wanted to get. So we're drawing a normal model. Why did I put 30 here? Remember, this number that goes in the middle of the normal model is always taken directly from your problem. Okay, I don't know if I can keep up the southern accent. Okay, your problem. Okay, so basically the 30 miles per hour was the posted speed limit, and that's what we would assume that on average people are going to be driving about 30 miles per hour. Maybe some were a little more, some were a little less. So 30 is going to be the middle of my model. And what I'm trying to prove is that if, based on my sample, if we're getting like really, really dangerously high or really dangerously low speeds, right? So we're trying to see if, if this detector displays the vehicle speed to its driver and if that's going to help slow down them. So they were trying to see if it actually if it's actually controlling the problem or not. Okay, so what we're going to do is we're going to have 30 as our mean, 31.5. Now, how did I get 31.5? Well, this is what I did. I went over in my calculator, and because we already have this in list 1, we can go to Stat, and then over to Calc, and then down to 1var stats. And under 1var in the frequency list, but we're using our data from list 1. Boom. Okay, so what is this? So this is X bar. Now, I don't know why, but for some reason I decided to use Y bar here. You could definitely use X bar. And remember, this is just the label on this. So for a sampling distribution, Y bar is the mean speeds of cars on this particular road, Triphammer Road. So the mean speed of different samples. These formulas down here, I'm going to explain in just a second how I got those. But this is setting up just the graph part of this. So 31.5, how did I get that? That was the mean based on my sample that I just found in 1var stats. Okay, now let's look at this part down here. These formulas come directly from the AP formula chart. So this is the mean. This is sampling distributions for means. So this is the mean. This is the standard deviation. This is the standard error. And remember, you use this when you do a t-test or a t-interval because you don't have the original standard deviation. Like for our problem, yeah, sure, we actually don't know what is the standard deviation of all cars on this road. So we're going to have to approximate it with the standard deviation for this particular sample. So I put a little X here because we're not going to do that middle formula. This is my mean. What this says is it says mean of Y bar. So this is the mean for the whole model, which is 30. Because we're trying to prove if it's above or below 30 miles per hour. And then we're going to use our standard error right here. So that's going to be estimated with S. Now, how did I get this S? Well, if I come back over to 1var stats, remember at the beginning of the year when we talked about what these different numbers meant? Yes, that was a long time ago, I know. But this little SX is what is going to talk about the standard deviation for this data. So 3.73 after I rounded it was my S. I divide that by the square root of the sample size and I get 0.795. So this number will come up here. Cool. Okay, so that's just the model part of it, and now we can actually get started on finding, yes, we want to find what the t-score is. Now to do a t-score instead of a z-score, right? Okay, so to do a t-score, you're going to use Y bar or X bar. Okay, I'm using Y here. You can use X. I'm sorry if that throws you off. Okay, it's the same formula basically. Okay, but the deal with this is that we always have to have a degrees of freedom associated with it, right? Yes, nod your head, yes, because that's what you need. So one thing I'm going to find before I get started is also, what is my degrees of freedom? You always want to write that down somewhere. So the degrees of freedom is going to be the number of your sample size minus 1. In this case, we've got 22 minus 1, so 21 degrees of freedom. And that is going to help me out when I find my t-score. Okay, find the t-score. So that would be 31.5, which is my y bar, minus mu, which is 30, divided by 0.795. You could do that real quick in your calculator, and you get 1.886. Okay, now why did I need that? Well, because in my original, when I'm trying to find this this here confidence interval, I'm going to need to know what's the mean plus or minus the t-score based on whatever degrees of freedom you have times the standard error of your mean. Okay, I'm about to show you guys where we got all these numbers because we already have all this written down. So what's y bar? Y bar is, for this problem, so y bar is your mean, which for this problem is 31.5, plus or minus. My t-score is 1.886 times the standard error. Oh wait, I already found the standard error. That was 7.795. Okay, and then what did I do next? Well, boom, chakalaka. What I'm going to do is just go ahead and simplify that. So I could multiply these two numbers together, add or subtract that from here. By the way, just a reminder that these numbers, when I multiply them, so I'm going to get 1.499. Please double check me and make sure that's what you got. This is talking about the margin of error. Anything I add or subtract to this number is margin of error. Here's another word for this. This is called the point estimate. The point estimate is whatever you found as a mean for your sample. Okay, well, what is this going to give me? Well, once I add and subtract them, so I'm just going to do 31.5 minus 1.499, and that's going to give me 30. Ooh, I hope that's correct. Okay, yeah, so this is going to give me 30.001, and then if I do 31.5 plus 1.499, I'm going to get 32.999. Great. Okay, awesome. So that's kind of what we get here, and now we can kind of move along to make sure that we are in a good spot. Now I'm curious. Sorry, I've got to try this real quick. What is this number? 886 times 0.795. I'm doing this because I'm getting different numbers right now. Oh, it's right. Okay, cool. All right, no worries. Good. Okay, so let's go ahead and let's move on. So this is my confidence interval. Real quick, let's do it in the calculator because why not? Okay, so if you'd like to do it by hand, great, but why not do a calc copy because it'll save you time. Yes, we want calc copies. Okay, so let's do that. So literally all you have to do is go to stat, go over to tests. Oh, let's see here. This is going to be oh, yeah, we already named it. We named it a one sample t interval. So we're going to go down to one sample. Oh, I passed it. One sample. Where is it? I don't see anything that says one sample. Oh, that's because it's going to just be under t-test. No, t-interval. Interesting. Do you notice something interesting here? Here is Miss Hickson trying to find this. We have one proportion, two proportion. We have all these different options, okay? Well, the cool thing is, if you can't find it, okay, like what's going on here is we cannot find one that says one sample, whatever. Just go to the one that just says t-interval if you can't find it. Okay, now we have the data, right? The data is in list 1. Boom, perfect. We don't need to add a frequency here. This is going to calculate it all based on here. Now, I do have to change my confidence level because that's going to be the same as what was in my problem. And in my problem, it was 90 degrees. Sorry, 90%, not degrees. So this is going to be 0.90. Okay, calculate. Cool. Okay, boom. Hey, oh my gosh, I got like almost the exact same numbers. That's cool, right? Okay, so it's gonna be maybe slightly different, but it should be basically the same, okay? So if you want, you could do a count copy. The biggest thing here is if you do a count copy, be careful. Why do I have to be careful, Miss Hickson? What do I need to be careful about? Well, this is what I'm gonna say. Please make sure that you are careful in making sure that when you do this interval, you have the degrees of freedom written down somewhere, okay? So here's what I'm going to do. I'm going to write x bar equals 31.5 s of x, which is my standard deviation, right? Standard deviation, okay, equals 3.73, and n equals 22. Now, there's one big thing you need to change. If for some reason, like Miss Hickson, you did a weird thing and you decided to use y on your picture, you would want to make sure that you came back over and changed the letters. It's kind of like what we did for hypothesis testing. So this would actually be y bar, and this would actually be s of y, okay? Now, here's the deal. If you use the calculator, don't forget to write what the degrees of freedom was. Degrees of freedom is always one less than the n. That's not something the calculator gives you, but it's something you have to write down, especially on AP tests. They expect you to write it down somewhere. It doesn't just anywhere, okay? So here's my confidence interval. I'll go ahead and copy that. Very, very similar to what we got before. So you can choose. Do you want to write only what's in the box, or do you want to write all the other work? It's your choice, okay? Last thing we're going to do is interpret this. So here's my interpretation. You probably know this back of your hand. You can say it with me. I am 90% confident that the true population, now we're not going to say proportion, what are we going to say? Mean, the true population mean speed of what? Of all vehicles on Triphammer Road is between, and then we're just going to go ahead and give some context and some units, is between, let's go ahead and do what we got in the calculator. So 30.1333 and, miles per hour, don't forget your units, and 32.867 miles per hour. Great. Now there's a quick question. We're just going to do this quick question together and then we're done, okay? The Department of Transportation believes that this speed traveled on this road is 30 miles per hour. Is there evidence based on this data that this actual speeds are higher? Interesting. Okay, so here's my data. Okay, so I just want to know, is there actually evidence to show that the actual speeds are higher? Okay, well, let's look at the number they give us. They really do believe, in their deepest, darkest hearts, they really do truly believe that the speed on this road is 30, that people are honest, loyal citizens, law-abiding, and never speed or drive slower. Is there evidence, based on what we got on our data, is there evidence based on this data that the actual speeds are higher? Well, let's see. Okay, well, here's my question. Is 30 in here? Okay? So I'm going to say, this is to answer the question, since 30 miles per hour is below, it's not in my interval, it's below my interval. I always compare the number they give me to the interval that I find. Since 30 miles per hour is below my interval, there is evidence to, what did they say? Evidence, is there evidence based on this data that this actual speeds are higher? There is evidence based on this data that the actual speeds are higher, because my whole interval, which is going to include 90% of my data and all data, 90% confident that it's going to be between these two speeds is the average. Okay, and this bottom number is higher than the 30. So since 30 miles per hour is below the entire interval, there's definitely evidence based on this data that the actual speeds would be higher, since both of my ends of my interval are above 30. If 30 had been inside of my interval, then no, I wouldn't really necessarily have evidence to believe that the actual speeds are higher. So now we've answered all the questions that were on the outline relating to Triphammer Road, and I hope you enjoyed the video. See you later.